Hey guys, welcome to Safi Mixed. In this video, I will let you know how to find the side length of an inscribed equilateral triangle in terms of radius of a circle. So to begin with, I redraw the circle in its original form and I represent the center of the circle with C and the radius of the circle with R, and then I draw an equilateral inscribed triangle in this circle, and I denote the vertices of this triangle with A, B, and D. Now we know that the total angle subtended by the circumference of a circle equals 360 degree. So if I join vertex B with C and vertex D with C, then that means I can divide the whole circle into three equal sectors. That is the sector subtended by the arc AB, the sector subtended by the arc BD, and the sector subtended by the arc DA. Since arc AB equals inlet to arc BD and BD equals inlet to arc BA, therefore the angle subtended by these arcs are also equals. That is, the angle ACB is exactly equal to the angle BCD is exactly equal to angle ACD. So we can write that ACB equals BCD equals angle ACD, and each of them is 1/3 of the 360 degrees. So I can write that 360 degree divided by 3, or another word, each angle subtended by an arc equals 120 degree. So that means the angle subtended by each arc equals 120 degree. So this angle is 120 degree, similarly this angle is 120 degree, and this angle is 120 degree. Now if I drop a perpendicular bisector from C on side AB and I denote the point with E, then the angle subtended by E with AB is 90 degree, and since this is a perpendicular bisector, therefore the angle ACE is half of the angle ACB. That is, I can write angle ACE equals half of angle ACB. And if I put the value 120 degrees, then I can write 120 degrees divided by 2, and this equals 60 degrees. That means the angle at point C is equal to 60 degrees. So now we know that, so now we have a right angle triangle AEC, and we know the angles on side CE, that is one angle is 90 degree and the other is 60 degree. Therefore, the side CE is base of this right angle triangle and side EA is perpendicular, and similarly the side AC is hypotenuse. And we know that the ratio of perpendicular to hypotenuse equals sine theta. Therefore, I can write AE divided by AC equals sine 60 degree. That is, AE this side divided by this side equals sine of this 60 degree, from which I can write AE equals AC times sine 60 degrees, and we know sine 60 degrees is equal to square root 3 divided by 2, so I can write it like this, and AC is in fact the radius R, so I put that value over here. It is AE equals square root 3 divided by 2 times R. This length from A to E equals square root 3 divided by 2 to R. And now the length AB is twice of AE because CE is a perpendicular bisector. Therefore, this side is exactly equal to this side. So I can write AB equals twice of AE. And if I put the value of AE from this equation, then I can write twice of square root 3 divided by 2 times R. I can cancel this 2 with this 2. That leaves me with square root 3R. Therefore, the length of, that is AB equals square root 3 times R. Similarly, BD equals square root 3 times R, and DA equals square root 3 times R. So this way you can find the length of the side of an inscribed equilateral triangle in terms of radius of the circle. Thanks for watching.